just make sure that you notice if it's weak or strong acids. Remember, greater than 1, strong acid, less than 1, which this one is, weak acid. That's usually the rule of thumb. It might change here and there based on who your instructor is or what they're using as a reference in terms of their textbooks, but that's usually the rule of thumb. Alright, so now let's see this question here. So question, it says, now at, let me just start from the top. So at 477 Kelvin, okay, and 645 millimeters of mercury, that's just a way to read atmospheric pressure. What volume, so how much N2 volume reacts completely with H2? How much of it? 29.2 liters, okay, to produce NH3. So the first thing we do here for this equation, we solve the formula. We have N2 plus H2 turns into NH3. So first thing we do is just try to balance it out. So you see here we have 2 nitrogens but only 1 in the products, so we need 2 nitrogens in the products. So now in the reactants though, we only have 2 hydrogens and 6 hydrogens in the products, so we need to multiply that by 3. This right here is a balanced equation. We're going to refer to converting our moles. Now we would need to go through all the steps of using this formula for per se, PV equals nRT, but this is one of those questions that's an exception of using this equation, because as you notice they said at 477 Kelvin and 645 millimeters of mercury. They did not say this changed. This question is constant temperature and pressure. So using that, and with, you know, following the laws of, you know, mass change and everything, you know, matter cannot be created or destroyed, it can only be changed and everything else, this allows us to just be able to convert straight from the moles to the volume, because of the fact that the temperature and the pressure stays the same. You don't need to convert the volume of hydrogen into the moles of hydrogen, and then the moles of hydrogen into the moles of nitrogen, and the moles of nitrogen back to the volume. You can literally just go into the ratio. So the normal steps, usually you would go volume of hydrogen, you'd use the PV nRT, so this formula here, you'd solve for the moles, so then you get the moles of hydrogen, and then use this formula up here to now solve for the moles of nitrogen, and then you'd convert it back using the PV nRT to volume of nitrogen. Now this steps here only applies when the pressure and temperature change in the process, but if those two stay the same, then that means the volume is now simply just a 1-to-1, or in this case 1-to-3 ratio. Okay, so here what I did to solve it is that the amount of volume, well actually these are right moles on top, the amount of moles per the amount of volume of nitrogen has to equal the amount of moles per the amount of volume of hydrogen. Okay, this is how I solved it, a much quicker way, only because the pressure and temperature were constant. Okay, so with that, we do not actually, we know the ratio of moles to hydrogen, so this is going to be 1, okay, it's equal to, and we know the hydrogen is 3, that, and also 29.2, that's the volume of hydrogen. And here, what's the volume of nitrogen? We don't know. This is our x. And we just solve for x. So then we end up with x is equal to 29.2 over 3. So that means the moles of hydrogen, well not moles, the volume of nitrogen, okay, it's just going to be equal to 9.73. And if you round it up, the only option that works is D. So the answer for this question is D. And the only reason why we're able to use a shortcut is, like I said, constant temperature and pressure. If not, please follow this way using the PV equals nRT equations on this step here when you convert from volume to moles, and this step here when you convert from moles back to volume, okay? If the temperature and pressure are changing. If you're not sure about this changing things or in terms of any of the constants that might be changing, just use the PV equals nRT so you can get the right answer. As you see here, that's what they did. They used PV equals nRT, and they were able to now, you know, break it down. They first went from the volume to the moles of hydrogen, and they found 0.633, and then they used that to find how much nitrogen, divide that by 3, so 0.211, and then they use PV and nRT again to get it back to the volume, and they do end up getting 9.73. So same answer, just different ways of working it. Just make sure you pay attention to what's given to you, okay? All right, so with that, let's move on to the next question.